right, hello geometry students. Today you are going to take your skills with volume that you've learned the past few days and you're going to apply them into what we call composite solids. So a composite solid is a solid composed of two or more solid figures. So these solids that you have can either be stacked or cut out from one another. So if the solids that we have are stacked, we add the volumes. If the solids are cut out, we subtract the volumes. All right, so let's go ahead and do a couple examples here. Start with number 1. So we're going to find the volume of the composite solid, round to the nearest tenth. Because a lot of these have circular bases, we want to make sure we use the pi button on our calculator. Okay, so if you haven't already been shown this, to access the graphing calculator on your Chromebook, you hit this white circle button in the corner. You arrow up here, and then it should be on the second or third page, and it says TI-84 plus. The pi button is found right here. You just have to hit second, and then we call this the caret key. All right, so let's go ahead and do this first one. So your two composite solids here on the bottom, you see how you have a circular base here and here. So if you have two circular bases, you have a cylinder. So we're going to start with the volume of the cylinder. So the volume of the cylinder is the area of the base times the height, where the base is a circle, so you do pi r squared. So this cylinder here, you have a circular base with a radius of 3, so we'll do pi times 3 squared. All right, so let's go ahead and go into the calculator and type that in. So second caret key gives me the pi times 3 squared. Hit enter. And then you're going to take that answer and you're going to multiply it by the height. So the height of the cylinder from here down to here is 8 inches. So I'm going to take this answer in my calculator and I'm going to multiply it by 8. So my volume is 226.2 inches cubed. So that's the volume of the cylinder first. All right, on top of that cylinder, you have a dome-like shape here. So what this is it is a hemisphere. So you're going to do the volume of a sphere, but then you're going to divide that answer by 2. So I'm going to take 4/3 pi times the radius cubed. All right, well, the radius of this hemisphere is 3 inches. So I'm going to do 4/3 times pi times 3 cubed. So my calculator, I'll type in 4/3 times pi. So second pi times 3, and then I'm going to use this button here to get my exponent of 3. And then whatever we get for that answer, then we want to divide it by 2. Because again, we are talking about a hemisphere. So I hit divide by 2 in the calculator, and we'll get 56.5, rounding to the nearest tenth. So now you have the two volumes you need. You have the volume here for the cylinder, this volume here for the hemisphere, and then you need to decide, are those solids stacked or are they cut out from each other? So they are stacked together, which means you'll take these volumes and you will add them. So we'll take the 226.2 and we will add the 56.5, and that's going to give us what we call the total volume. So 226.2 plus 56.5 will give us a volume of 282.7. Your units are inches cubed. All right, now let's go to part B here. This time when you look at your figures, notice that you have a cube with a cone that is cut out of it. So when you do your two volumes, instead of adding, you will subtract. All right, so let's start with the cube. So the cube is a type of prism, so you'll do the area of the base times the height. Well, if you're calling it a cube, then you're saying that the shape of this base down here is a square. So we are going to take 7 squared, or you can just do 7 times 7. So the base area is 49, the height is 7. So the volume will be 49 times 7. And so I'll go to the calculator, I'll do 49 times 7, and I will get 343 inches cubed for my first volume. So I'm going to make sure I point an arrow to that because I want to make sure I can reference that volume later. All right, now we want to do the volume for our cone. And Mrs. Klimek does not know how to spell cone, apparently. C-O-N-E. So the volume of a cone is 1/3 the area of the base times the height. Well, the base is going to be equal to pi r squared. So the radius of this circular base here is 2, so I'm going to do pi times 2 squared. So let's go to the calculator, type that in. So pi times 2 squared gives you a base area of 12.56637061. All right, now you want to multiply that base area by the height of the cone. So go inside here. It doesn't necessarily say what the height is, but the circular base of the cone down to where the tip of the cone is the entire length of this cube. So whatever the height is out here is going to also be the height in here. So it's not mentioned inside the cone, but if the outside height is 7, then the inside height is also 7. Okay, so we're going to take 1/3 times this base area times 7. So I'll do 1/3 times, I'm going to hit second answer so it can copy that base area in, and then times 7. So my volume is 29.3. And that's inches cubed. So I have my 2 volumes. I'm ready then to find the total volume. So I'm going to use TV up here for total volume. So you're going to take the bigger number, 343, and subtract the 29.3. All right, so 343 minus 29.3. So your total volume is 313.7. And your units are inches cubed. All right, so I would go ahead and pause here and work on finding the volumes of these composite solids on your own. And then when you're done, hit play and check how you did. All right, so you guys just worked on finding the volume of these 2 figures. So let's see how you did. On part A, we have a prism here on the bottom stacked with a pyramid on top. So again, when they're stacked together, that means you are going to add your volumes. So let's start with the prism. So the volume of a prism is the area of the base times the height. So the prism is down here on bottom. Here is what will make the base. So we'll take 12 times 8 and get 96. And the height is 10. So the volume would be 96 times 10, or 960. So there's your first volume right there. All right, now we're going to do the volume down of this pyramid here. Notice that this pyramid shares the exact same base in common that the prism had. So you have a rectangular pyramid. Your volume is 1/3. the area of the base times the height. When you go to do the area of this base, you will also do 12 times 8. So you're going to get 96 again. Your height for your pyramid here is 3 feet, because from the base of the pyramid up to where the point is 3 feet. So your volume is 1/3 times 96 times 3. So let's go to our calculator here. We'll type in 1/3, 1 divided by 3, times 96 times 3. And our volume will be 96. All right, so then we can take our total volume by taking the two that we just got and adding them together. So 960 plus 96. And again, I use TV for total volume, you guys. So 1,056, and our units are feet cubed. All right, so for part B, you have actually this time 2 prisms. You have a prism that's being cut out of a larger prism. So this time when you do your total volume, instead of adding, you will subtract. So let's start with the big prism. So the volume is the area of the base times the height. So we'll call this the base of this. Notice it says 5 inches, 5 inches, and 5 inches. So I'll do 5 times 5. And the height is also 5. So when I do volume, I'll do 25 times 5. And so your volume for the big prism is 125 cubic inches. And now we're going to do the volume for the inside prism. So we'll call this here the base of that. And then when we go to do our height, notice that the height from the inside is going to be the same as the height that's on the outside. So they don't put it here, but we're going to use 5 inside here as well. So the other prism, so volume equals base times height. The base will be 2.1 times 2.1, which is the same as 2.1 squared. All right, guys, I'm going to run out of room here, so I'm going to bring this up here. So I have 4.41, and I need to multiply that by the height of 5 for the volume. So that would be 22.1. So this is your other volume here. Now that we have our 2 volumes, we'll take total volume. So since they're cut out of each other, you'll do the big one minus the small one. So 125 minus 22.1. So 125 minus 22.1 will give you 102.9. And your units are inches, so inches cubed. All right, so here it says find the volume of the composite solid, round to the nearest tenth, and then again use the pi button on your calculator. So this solid here, you have 2 solids stacked on top of each other, so you're going to add your volumes. You have a cone and then you have a hemisphere. So the volume of a cone is found by taking 1/3 the area of the base times the height, and the base is pi r squared, while the radius of the cone is 6. So let's take pi times 6 squared. And then we're going to take that answer from our calculator and multiply it by the height, which is 17. So I'm going to take 1/3. I'm going to multiply it by what's in my calculator. So I'm going to hit second answer and then times the height of 17. and I'm going to get 640.9. So there's the first volume for your cone. All right, now let's do the hemisphere. So a hemisphere is just half of a sphere. So let's go ahead and take the volume for a sphere first. So the radius of our sphere is also 6. So we'll do 4/3 times pi times 6 cubed. And then whatever answer you get in the calculator, you are going to divide that by 2. So 4 divided by 3 times pi, so second caret key, times 6, and then exponent 3, hit enter, and then take your calculator, hit divide by 2, and you get 452.4. So here is your other volume. So now you've got your 2 volumes. So you should be able to find your total volume. So total volume is the 640.9 plus the 452.4. And you get 1093.3. And your units are feet, so feet cubed. All right, last one is an application problem. So let's make sure you read carefully. You do have a picture, so that does help. So assume an automatic pet food feeder is a cylinder on top with a cone of the same radius. So you have a cylinder and a cone put together to create this pet food feeder. So for part A, we want to know what is the volume of the pet food feeder. So let's do the cylinder, and then we'll do the cone. And then because they're stacked, we will add those volumes together. So the circular base of the cylinder here is the same as the circular base for the cone, which does help us a little bit. So volume will be the base times the area of the base times the height. So we'll do pi times 2.5 squared for the area of the base. And then our height is 7.5. So let's type this in. So I'm going to hit pi times 2.5 squared. And there's the area of my base. And then I'm going to take this same value in my calculator and I'm going to hit times 7.5. So the volume for the cylinder is 147.3. All right, so now we'll do the cone. So the cone is 1/3 the area of the base times the height. So when I do the area of the base, we'll do pi times 2.5 squared. And the height for the cone is 4 inches. So in my calculator, I will do pi times 2.5 squared. Then I'm going to take that value. So I'm going to do 1/3 times. I'm going to hit second answer. So it copies what was in my calculator before. And then times 4. And it gives me the volume here to be 26.2. So I have my volume for the cone and the volume for the cylinder here. So we can find the total volume of the pet food feeder by adding these together. So 147.3 plus 26.2. And that will give you 137. Whoops, I typed in 0.5 instead of 0.2. So let's try that again. 147.3 plus 26.2. 173.5. And your units are inches cubed. So there's the total volume for the pet food feeder. Now for part B, it says how many cups of pet food can you put in the feeder? And that is where this right here comes into play. You were told that 1 cup is equal to 14.4 inches cubed. So what you're going to do is you are going to take the 173.5 and divide it by the 14.4 because you want to end with cups. So you're going to basically take the inches cubed and divide them so that cups is what's left. So in the calculator, I'm just going to hit divide by 14.4, and it is about 12 cups. So you can fit about 12 cups into the pet food feeder. All right, so that is the end of the lesson for composite solids. So please ask if you have any questions and make sure you work on your practice. All right, good luck.